Hello students, welcome to the another video of understanding quadrilaterals. In previous video, at last we have solved question number 2, and in question number 2 we solved only first one. Okay, so in today's video we are going to continue this question number 2. Okay, so let's start question number 2. Let's draw second parallelogram and find the value of x, y, z. See, the unique one is okay. It is x, it is y, 50 and z degree. Okay, so we have to find x, y and z. So again, same as question number 1, we will use the property of parallelogram, and we are given that all the diagrams are parallelogram. Okay, and we are finding measure of angle, so we will use only two property, one for adjacent angles and one for opposite angles. Opposite angles are equal in parallelogram and adjacent angles are supplementary in parallelogram. So let's find first y. So y is, we will use two property for opposite and for adjacent. So find adjacent angles, angle of y. So it is 50 degree. Okay, 50 degree. And we will not write in very deeply. Okay, we will show only. Okay, because we know the property, and x is opposite, so we can directly write that. Okay, so we will use this 50 degree. Okay, so yes, we can directly write that. Okay, let's name this, so it will be easy and very systematic. So let's name it A. You can name it, okay, but at last you have to write that x is equals to this, y is equals to this, because your teacher will find the value of x, y, z. Okay. So here, measure angle ABC. Measures can be opposite or adjacent. Okay, angles can be opposite and angle adjacent. So angle ABC and angle BCD are adjacent. So measure of ABC plus measure of BCD is equals to 180 degree. Measure of ABC is given 50 plus BCD is y is given as y degree. So transpose this 50. So 180 minus 50, 130 degree. See, whatever you have studied in chapter number 1, it will come in this coming chapters. Okay, so it is y is equals to 130 degree. And see, this transportation of this variables at right hand side to LHS, LHS to RHS, it is the base of chapter number 1. Whatever you have studied in chapter number 1, it will come in further chapters. Okay, and it will be beneficial if you have studied chapter number 1 and 2 very properly. Okay, so this y is equals to 130 degree. So okay, we get 130. Now we can directly write that measure of this BAD is equals to 130 degree, because this BCD and BAD are opposite. Okay, so let's write. Okay, so see, measure of BCD equals to measure of BAD, because it is called because. Okay, because angle BCD and angle BAD are opposite. So BCD is equals to 1 130 degree is equals to, and it is given as x, so x is equals to 130 degree. And if you talk about z, see, we have this type of diagram. It is 130 degree, it is 130 degree, and our z is given here, and it is called exterior angle. Okay, this degree z is exterior, measure of exterior angle. So first we have to find this interior, and then we can find the measure of this z. Okay, A, B, C and D. So let's find first CDA, this CDA. So CDA is, oh sorry, okay, CDA, which property will you use? Yes, either adjacent angle, either of adjacent angle or of opposite angle. So yeah, we will use adjacent angle. So this 130 degree, so it is, so we can write, yes, angle BAD and angle CDA are adjacent. So measure of BAD plus measure of CDA is equals to 180 degree. Measure of BAD is given 130 degree. Let's assume as Z dash. Z dash is equals to 180 degree. So Z dash is equals to 180 minus 130 degree. It is 50 degree. We can okay. We can use property of opposite angles because it is given 50 degree. So these two are opposite. So we can directly write that this CDA Z dash is equals to 50 degree. Okay, so now we have this interior angle. See, this interior angle 50 degree, and we have to find this Z. Okay, so in earlier videos we have seen how to find this type of measure of angles. See, this whole is 180 degree. This whole is 180 degree. We have this part 50 degree. So remaining part is, this Z is 180 minus 150 degree. So measure of C, D, and let's write as E. So CDE is equals to 180 degree minus measure of CDA. And measure of CDA is equals to Z dash. Z dash is equals to 50. So it is 130 degree. And you can use also Z rule here. See, this B, C, D, E is Z. So inner corners are equal. So which are inner corners? B, C, D and C, D, E. This and this. These two are inner corners. So we can directly write also. Because these two are parallel lines, and one line is crossing this parallel line, these two parallel lines, and we have found Z. So we can directly write that inner corners are inner corners are equal. Inner corner are equal. Sorry for this mess. This and this. Okay, these two are inner corners. So this was second parallelogram. Okay, let's move on third one. Okay, third one. See what I did. Okay, let's not. Let's redraw. So I have to make first this, then this. Okay, let's